So yesterday's lesson we graphed one that was a little bit obvious. It was a circle, but graphing's not always going to be obvious when you graph it with polar coordinates. Remember, the tips are that x is equal to r cosine theta, y is equal to r sine theta. We know that x squared plus y squared is equal to r squared, and we know that the tangent of theta is equal to y over x. If you can keep those in mind, then graphing in polar coordinates is going to be a little bit easier. So, for example, let's do some examples of ones that we have to do. Example 1, radius is equal to 3. Well, that one should be evident about what it is, and it's actually a lot easier of an equation to use than the rectangular form of that. If all I know is that the radius is 3, then I should know that what I have is a circle. And when I graph that circle of radius 3, I get the radius 3, and it doesn't matter what angle that we have. So if I have an angle, hang on a second. So in any case, angle can be anything. So as we zoom around with an angle of anything, but a radius of 3, we're just going to get the equation of a circle of radius 3. So that is the equation of r equals 3. And if you translate that to rectangular, you're just going to get x squared plus y squared is equal to 9, centered at 0, 0. For our next one, we're going to do just a constant angle. Theta is equal to pi over 4. So if theta is equal to pi over 4, radius is equal to whatever. And if radius is anything, then that means radius can be both positive values, negative values, and 0. So if I do an angle of pi over 4, that's a 45-degree angle, it's going to come out like this, but it's also going to dip down like this, because remember, we can have positive radii or negative radii. And this is obviously the equation y is equal to x. I can get that by knowing that the tangent of theta is equal to y over x. So in this case, the tangent of pi over 4 is equal to y over x, or 1 is equal to y over x. And I get the equation y is equal to x, if you want to convert that. Let's graph another one. Let's graph r is equal to 2 times the secant of theta. So sometimes it makes sense just to try to convert these to sines and cosines, so we can kind of perceive it a little bit easier. I know that r would be equal to 2 over the cosine of theta. And if I multiply both sides times cosine theta, I get r cosine theta is equal to 2. We know that r cosine theta equals is just x, so that's just x equals 2. And again, if you graph that as x equals 2, what you should see is just a vertical line sitting at, oh, hang on, didn't mean to do that, but we'll let it sit, sitting at x equals 2. Okay, next one, let's try r is equal to 5 times the cosine of theta. So this one's going to be just a little bit more challenging. 5 times the cosine of theta. If I convert the cosine of theta into x over r, I just get 5x over r. Well, then when I multiply both sides by r, I get r squared is equal to 5x. And we know that r squared is equal to x squared plus y squared. So if x squared plus y squared is equal to 5x, then I can subtract and set both sides equal to 0. X squared minus 5x plus y squared equals 0. If you complete the square, you're going to get x squared minus 5x plus, if I go half of 5 and then square it, I get 25 fourths plus y squared is equal to 25 fourths. And you get x minus 5 halves, quantity squared, plus y squared is equal to 25 fourths. And this is just a circle with a center at 5 fourths, comma 0. So let's put a grid down, or 5 halves. So 5 halves is 2.5, and then my radius is also 2.5, so I go up 2.5, left 2.5, down 2.5, right 2.5, and just kind of sketch this circle. That was bad, but you get the idea. Okay, next one. Sorry, this is number 5. If I do r is equal to 4 over 1 plus the cosine of theta. So I don't like this fraction form, so we're going to make it r plus r cosine theta is equal to 4. I know that r cosine theta is equal to x, so I have r plus x equals 4, yeah. And I get r is equal to 4 minus x. Well, we have a substitution to make for r squared, so if I say r squared is equal to 4 minus x quantity squared, I know r squared is x squared plus y squared. I can make that equal to 16 minus 8x plus x squared. And interestingly enough, my x squareds cancel out, and I get just kind of a y squared with an x. Well, if I move everything around, I get negative 8x is equal to y squared minus 16. This is a parabola where I get x is equal to negative 1/8 y squared plus 2. And what I know about that parabola is that it's going to be a left opening parabola. I know that my c value is equal to 2, and that's plenty to plot some of the critical points of this parabola. Sorry, let me go back down and get my grid out. So I know that my vertex would be at 2, 0. I know that if c is 2, then I put a focus at the origin, put a directrix at x equals 4, put my symmetrical points up 4 and down 4 from the origin, and I can graph out a nice looking parabola. It also includes its x and y intercepts, so that's good. Number 6, I know that if I go r is equal to the tangent of theta, let's try to graph that. Get r is equal to y over x if I convert tangent. Then I just need to convert r. Well, I can do the same trick from before. I can make it r squared is equal to y squared over x squared. And you get x squared plus y squared is equal to y squared over x squared. And if I multiply both sides by x squared, I get x to the 4th plus x squared y squared equals y squared. Well, this one's tricky because I really don't have a good way to get y by itself. So the best I'm going to be able to do is just get an equation, but I really won't be able to graph it. So if I move the y's to one side, get y squared minus x squared y squared, and factor out a y squared, I get x squared equal x to the 4th is equal to y squared times 1 minus x squared. Divide both sides by that. I get y squared is equal to x to the 4th over 1 minus x squared. And this is plenty for what we need. I know I'm not going to graph that. I cannot graph it really. But I did want you to see what that kind of looks like. Okay, next one. We're going to do y squared is equal to 4x. And we're going to convert to polar. Well, converting to polar is a lot easier than converting to rectangular. So all I have to do is substitute r sine theta and r cosine theta. So if I substitute r sine theta equals 4 times the cosine of theta, what I really want to do is convert to polar, and I want to solve for r. So this gets me r squared. And if I sine squared theta equals 4 cosine theta, and oh, I forgot this r here, r cosine theta, r sine theta, or r cosine theta, r cosine theta. When I divide, I get, let's see, I want to move the r's to one side, so I'm going to divide both sides by r and get r sine squared theta is equal to 4 cosine theta, and then divide both sides by sine squared theta, and you get r, or 4 cosine theta over sine squared theta. So there we've got this by, we got r by itself. And just be careful because right here I messed up and didn't put the r in right away. We can convert just a basic line. So I go 4x minus 5y is equal to 7. Again, if I substitute, I get 4 r cosine theta minus 5 r sine theta is equal to 7. And this is just a matter of factoring the r out of the left side and then dividing both sides by what's left. So you get r is equal to 4 cosine theta minus 5 sine theta. And then you have that equation in polar form. I think we're done.